again. In section 7.2, we are going to learn how to multiply and divide two rational expressions. And again, we'll start from the review of the fraction numbers. If I have two fraction numbers, 1/3 and 1/2, how do we multiply the two fraction numbers? Recall what we did in pre-algebra. To multiply two fractions, we are going to just multiply the two numerators. 1 times 1 is 1. 3 times 2, that's 6. So then we get 1/6. And this is a fundamental rule. This rule can be applied to the rational expression. To multiply two rational expressions, we just multiply the numerators and then multiply the denominators. That's it. But the problem is, for example, if I have this one, 1/3 times 6/5. When we multiply those two here, we'll get 1 times 6, 3 times 5. If you simplify, multiply the numerator denominator out, you'll have 6/15. And then see, can you leave the answer 6/15 as the final answer? The answer is no. We know for any fraction number, we have to simplify or reduce the number as much as possible. 6/15. This is not a simplified number here. We can simplify this. If we divide 6, so both of them a factor of 3. So divided by this by 3, we got 2. Divide this number by 3, we got 5. So 2/5 should be the final answer. If we have to do this for the fraction number, we should do this to the rational expression as well. So when we multiply two rational expressions, we do need to multiply the numerator and denominator respectively, but we have to make sure our final answer is simplified. And remember, what I just showed you right here is not the best way. So when actually, if you recall, when we do the multiplication of fraction numbers, after we write this one here, I believe your professor should have told you, no rush to multiply the numerator and denominator out now. So don't get 1 times 6, 6, 3 times 15. Don't do this. This is okay, but not the best way to do that. What's the best way? So instead of multiplying those numbers out, you do the opposite. You factor every number if it is possible. So 1 is 1. 6 can be factored, replace 6 by 3 times 2. Can you factor 3? No. Can you factor 5? No. So factor any number that is possible. And then what do? Cancel the common factor. 3 are the same. They cancel each other. There is nothing else in common. Now you multiply the remaining factor out. 1 times 2 equals 2. 5 is the only number left on the bottom. That's it. This answer is the final. When you get this one, you never need, should I check if I can continue to simplify this number? No worries. This will always be a simplified fraction number, final answer. You don't have to try to simplify this anymore. So this is what we did before. So now I want you to remember this way here. When we are multiplying two rational expressions, we are going to multiply numerator by numerator, denominator by denominator. Instead of multiplying them out directly, we are going to factor each polynomial if it is possible. If it cannot be factored, then they stay in one parenthesis. After you factor everything which is possible, then cancel the common factor. Multiply the remaining things out. This is what we are going to do here. Okay, so for example, what I'm going to do here, I'll give you a few problems. This one. So when I do the multiplication, step one, draw a long bar. So don't be afraid of wasting your time. At the beginning, for a beginner, just follow every step, do one thing, draw a long bar. Then you put numerator, 3x minus 4, so this one numerator stays in one parenthesis, times another numerator, 5x plus 3. So please remember, I want you to highlight, put each numerator in one parenthesis. Keep the parenthesis, very important. And the second, no, and then work on the bottom. The first denominator, 10x plus 6 times 6x minus 8. Okay, so we have done the multiplication, but we haven't finished it yet because we have to simplify this new rational expression. So this new rational expression has a numerator, has a denominator. Now what do we do? Do not ever try to use the FOIL rule. Break them down. Don't do this. Instead of multiplying, what do? We do the factoring. We'll see, can we factor each parenthesis? First one, can we factor 3 minus 4? No, nothing in common, not difference of square. Can we factor 5x plus 3? No, it is prime. Then we'll see, can we factor 10x plus 6? Do they have any GCF? Yes, it has GCF 2. So factor 2 out, got the 5x plus 3. And for the second denominator here, 6x minus 5, how can we factor it? GCF. I have another 2 here, multiply 6x divided by 2, 3x minus 4. Now we'll just use our finger and eyes, do the same thing. So I point, oh, I see 3x minus 4, beautiful, they cancel each other. I see 5x plus 3, 5x plus 3, those two cancel each other. Okay, and then what do we get? Alert, okay, a very common mistake is, oh, the students will see, oh, there is nothing left on the top. Now on the bottom, I have 2 times 2, oh, 2 times 2, multiply them out, that's 4. Final answer. That is wrong, okay? And don't forget, you can never change the location of the number. Where are those 2 2's? 2 times, they're under the bar. They'll still be under the bar. If there is no number left on the top, what do? We put 1 there because everything equals themselves times 1. When those 2 factors are canceled, we still have 1 left. So if no number is left on the top, put 1 here. Those 2 2's, they're staying on the bottom. They still stay on the bottom. You cannot just flip them. 1/4 is the final answer. Okay, so this example, I like this example very much. A very common mistake happens if we don't pay attention to this. So if there is nothing left on the top, always put 1 there. Okay, so now let me grab another one. So number 9. This one looks pretty complicated. So multiply, no matter how complicated those rational expressions look like, don't be afraid. Just follow the step. Step 1, just draw 1 long bar. Then multiply the 2 numerators. First one, m squared minus x minus 6 times the second one. Don't forget the parentheses. Please remember the parentheses. M squared minus m minus 20. Okay, so this is the numerator. So numerator 1 times numerator 2 over what? Over denominator 1, m squared plus 5m plus 4 times what? Times m squared minus 8m plus 15. So this step 1. Step 2, I will go through every single parenthesis and try to see, can I factor any one of them? I look at the first parenthesis, trinomial, leading coefficient is 1. That's -6. So look for two numbers. Product is -6, sum is -1. What are the two numbers? 2 and -3. So this polynomial, this trinomial can be factored as m plus 2, m minus 3. Second polynomial. Still, leading coefficient is 1. So two numbers. Product is -20, sum is -1. 4, 5 is 20. And if I have -5 and +4, their sum will be -1. So then m plus 4 times m minus 5. So I factored each one of them. So keep writing them. So they're all multiplying together. Move on to the denominator. First polynomial we see here, leading coefficient is 1. So 1 times 4 is 4. 1 plus 4 is 5. That's simple. 1 and 4. Two binomial. And check the last one. 15. 3, 5, 15. 3, 5 can get an 8. To get a -8, both of them should be negative. So then that will be m minus 3, m minus 5. Okay, so now what do we have now? You might, use a finger and your eye together. So do I see m plus 2 on the bottom? No. Do I see m minus 3? Great. M minus 3, m minus 3. So those who cancel each other. Then I see m plus 4. Do we see another m plus 4 on the bottom? Yes, those two cancel each other. I see m minus 5, m minus 5. So 3 pairs of common factors canceled each other. What is left? M plus 2 is the only one left on the top. You do not need to keep the parentheses anymore. And on the bottom, there is only one polynomial, no parentheses. This is final answer. See, when you are doing this problem, it's very satisfying. We start with a very complicated multiplication of rational expression, but it will end up with such a simple expression. All done. 100% correct. Final answer. Okay, so just remember the 2 steps for the multiplication. The last thing that we are going to do is what? So multiplication is one operation. Another one is what? Division. So if we go back here, so when we are working on fractions, 1/3 divided by 1/2. If you still remember, how do we do the division of fractions? You might remember. So instead of dividing a rational expression, we are going to turn the division into multiplication. The first number stay the same. Divide turns into multiply, and then flip the divisor. So this is a dividend. This is a divisor. Flip the divisor. 1/2 turns into 2/1. And then you're going to multiply. 1 times 2 is 2. 3 times 1 is 3. 2/3 is a simplified fraction. Final answer. And I have heard so many students said, oh, professor, my teacher used to tell us to cross multiply. So see, the top will be 1 times 2. The bottom will be 3 times 1. See, same thing. 1 times 2 on the top. 3 times 1. So this is what actually we are doing. How do we multiply those two fractions? Numerator times numerator. 1 times 2. See, 1 times 2. And what is denominator? 3 times 1. 3 times 1. But I am not a fan of the cross multiply method here because sometimes it's really confusing. How do you know which multiply, you do the first. So does 3 times 1 go to the top or 1 times 2 go to the top? I'm always confused. I said, I never tried that one. I also want you to follow this, the new way, if you're not, you don't remember how to do this problem anymore, follow my way now. So this is my way. Whenever we do the division, we always turn the division into multiplication. The first number stay the same. This division turns into multiplication. Then flip the second number over, 2 over 1. Now the next thing we do will be working on the multiplication. Numerator times numerator, denominator times denominator. And this rule can be applied to the rational expression division. Okay, so quick example here. What we are doing, so this is one rational expression. Divide another rational expression. What do we do? No division anymore. Turn the division into multiplication. Then flip the divisor over. W over 4 stay the same. Multiply, divide means turns into multiply. Then flip those two, W over 4. Okay, and then gradually you can skip the step, like you write down W times 24 and so multiplication, like what I showed you. Step 1, draw a long bar, numerator times numerator, denominator times denominator. But gradually you might skip that step. Okay, see this one here. Now what do? You just try to cancel. W cancel out. 24 divided by 6 equals what? 24 divided by 4 equals 6. Final answer. Or you see, divide both them by 4 here. 24 divided by 4 is 6. 4 divided by 4. See, nothing left on the bottom. If nothing left is bottom, it means we have 1 here. But everything divided by 1 equals itself. So do not, another thing I want to remind you, do not leave the answer as 6 over 1, because everything divided by 1 equals the number itself. So this is a not simply for the version. We do not accept 8. We accept 6 only. So when the denominators are all gone, then you do not have the bar anymore. If nothing is left on the top, we still need to keep the bar and we put 1 on the top. So this is the only difference. All right, so this is one example. And let's look at another one. So what do we have here? We are going to, okay, so flip. The first one stay the same. Turn the division into multiplication. Then flip the second one here. And now you're going to see I have rational expression times another rational expression. The numerator times numerator. So x minus 2 times x minus 5. Okay, don't forget the parentheses. And the denominator x plus 2 times x plus 6. Now we'll see, can I factor any one of them? None of them. None of the parentheses, none of the binomials here are factorable. So they're all prime. And then what do we do? Stop here. You don't need to do anything else. You might ask me, Professor, do we have to carry the multiplication out? The answer is no. Leave the expression in the factor form. You do not need to use the FOIL rule to carry the first multiplication, second one. This is one acceptable final answer. That's it. Leave this here. Final. Okay, do not move forward, multiply them out. We don't do this. Just keep this one. Final answer. Let me give you one more example. Okay, to do the division. What do we do? Keep the first one, k squared plus k minus 2 over k squared minus 4. Divide turns into multiply, and then flip the second one. So this step, do not skip it. K squared plus k minus 6 on the top, k squared plus 5k plus 6 on the bottom. And the next step here, I'll say you do not need to rewrite them, so you can just directly try to factor them. So first numerator, k squared plus k minus 2. Can I factor this numerator? The answer is yes. It can be factored as k plus 1 times k minus 2. 1 negative 2. Product is negative 2. Sum is, no, I'm wrong. The sum should be positive, so then 1 should be negative, 2 should be positive. Okay, 2 negative 1. 2 plus negative 1 is positive 1. Then, okay, don't forget, times the other numerator. So can I factor the second numerator? Negative 6. Sum is 1. So that should be 2, 3, and 3 should be positive. So k minus 2, k plus 3. So be careful when you do the factoring here. The second, now we move on the bottom here, over, so just 1 long bar here, over k squared minus 4, k plus 2, k minus 2. And we have this one, k squared plus 5k plus 6, 2 times 3, that's 6, 2 plus 3, that's 5, so k plus 2, k plus 3. So what I did here, I combined the two steps. So write down a long bar, numerator times numerator, and then factor each polynomial if we could. And I did the factorization. So just keep this long bar here. Now, that is the best step here. Just check, do we see anything in common? See, I see k plus 2. I see k plus 2 here. There is another k plus 2. It stays. There is nothing to cancel this one. This can only cancel one fact. Now I see k minus 2, k minus 2. I see k plus 3, k plus 3. All right, what is left? Only one binomial left on the top. No parentheses is needed anymore. And then we have k plus 2 on the bottom. This is a division problem here. So multiplication and division are very, very similar. There is just one more steps in division. Flip the divisor over, turn the division into multiplication. And then multiply horizontally. Numerator times numerator. Denominator times denominator. Then instead of doing the multiplication, we actually do the opposite. We try to factor each polynomial. After we factor them, cancel the common factors, write down the left over. If there are multiple factors are left, just keep them as a multiplication form. Just make sure you put them in parentheses. You do not need to actually multiply them out. This is the division. See, whatever we have done in fraction number, we barely did anything. So what we did today, nothing new. We just put all the ingredients together. We have learned how to work on fraction numbers. We applied the rule on rational expressions. And then we learned how to do the cancellation. How? You have to do the factorization. This is what we did in chapter 6. Factor. And then the cancellation, just whatever you see in common, cancel them. That's it. This is section 7.2, the multiplication and the division of rational expressions. We started those two operations first, and we haven't done the addition and subtraction. When we are working on the numbers, we always start with do the addition first, then do the subtraction, then multiplication and division. And here we actually follow another order. Why? Because the multiplication and the division are much easier than addition and subtraction. So that's why we start from the easy thing. And then we move on to the more harder things. So next week, we will be working on addition and subtraction of rational expressions. Be prepared. That will be very, very challenging. Okay, one problem might use a whole piece of paper if we get a pretty complicated, when the problem is complicated enough. And okay, so that's what we want to go over today. And if you haven't finished the first midterm 791, the due date is, I think it's 26. You are allowed to take the test up to 3 times. I will use the best score. So if you are not happy with your first try, go ahead, take another one. I do not use the average. So just try and just make sure you finish the exam before the due date. All right, so that's what I want to share with you today.